Hi everyone, welcome. Today's class is qualitative analysis. So actually this chapter is practical organic chemistry. In this practical organic chemistry, three parts are there. So the first one is qualitative analysis, second is quantitative analysis, third is purification of organic compound. Today's class is regarding qualitative analysis. Okay, so in this qualitative analysis, generally we take any organic compound. For suppose you take any organic compound like methane. Generally any organic compound contains carbon and hydrogen, but some organic compounds contains nitrogen, oxygen, sulfur, halogens, these elements also, right? So we have to detect whether one organic compound contains carbon and hydrogen or not, or whether one organic compound contains nitrogen, oxygen, halogen elements or not. Okay, so how you can detect those elements, which elements are present in one particular organic compound? If you want to know, you have to go through qualitative analysis, right? So in this qualitative analysis, today's the first method is Liebig's method. Liebig's method. Liebig's method. This is very important for IIT-JEE mains, advanced 11th and 12th class students. Okay, so in this Liebig's method, for suppose you take combustion reaction. I hope you people already know about the combustion reaction because this is the very famous reaction. For suppose I am taking CH4 organic compound, because carbon and hydrogen are there. In 99% of the cases, almost 99% of the organic compounds always contain carbon and hydrogen. Whenever I am heating this organic compound in presence of oxygen, always these organic compounds will give carbon dioxide and water. This is very famous reaction, right? Okay, so in this Liebig's method, for suppose I am giving this organic compound. At the initial stage, I am not telling you that this is methane solution. I am just giving one solution, one organic compound solution to you, and I am asking you to detect which elements are present in this organic compound. Then what you have to do? You have to go through this experiment. So what is this experiment? Just listen carefully. This is the Liebig's method. In this Liebig's method, how can you find out whether one organic compound contains which element? Dekho. First of all, I am taking one tube here, right? I'm taking one tube here. So in this tube, I have one organic compound. For suppose take methane, right? So along with organic compound, copper oxide is also there. Copper oxide is also there. That means I am heating this organic compound with this copper oxide. This is the heat, right? So this is the heat. I am heating this organic compound with this copper oxide. Now through this pipe, when I am heating one organic compound, vapors will release. So these vapors are just passing through this pipe. Here one bulb is there. So in this bulb, I have anhydrous copper sulfate, which is in white color. Anhydrous copper sulfate, which is in white color. Okay, listen carefully, which is in white color. Okay, first of all, what happened? I am just heating this organic compound with the copper oxide. Vapor will release. Now this vapor is passing through this bulb. In this bulb, we have this anhydrous copper sulfate, which is in white color. So whenever this anhydrous copper sulfate, okay, absorb this vapor, okay, absorbing this vapor. So on absorption, okay, so if this white color will turn to blue, then it clearly indicates water is present in this vapor. Okay, so whenever water is present, that means hydrogen is also there in the organic compound, because in water hydrogens are there. That means this vapor belongs to this organic compound. So our organic compound has hydrogen. So here two conclusions. So first conclusion, this organic compound contains hydrogen. So this hydrogen is reacting with this copper oxide. This is the first step. Okay, so hydrogen, copper oxide balance the reaction. Here hydrogen, we have to get H2O. So hydrogen, 2 hydrogens I'm taking here. So H2O plus copper metal. Okay, this is the first reaction. Second reaction. Here water is present because white color turns blue. That means this is the indication of the presence of water. So water, that means water is reacting with copper sulfate. So water is reacting with copper sulfate. So initially this copper sulfate is in white color. So now this copper sulfate, white color, turns to blue. Copper sulfate 5H2O. Here 5H2O, here 5H2O. So this is blue color compound. So this blue color compound is saying that water is present in this organic compound or in this vapor. So whenever we have the water, that means hydrogens are present. So like this we can detect hydrogens are present or not. Next, so in this organic compound, carbon is present or not. How we can get to know? Okay, these two reactions are only important. You don't need to remember this whole experiment. So for your competitive examination point of view, you have to remember these two reactions here. Okay, this reaction is important and this reaction is important. Okay, so after this, how you can get to know whether carbon is present or not? Okay, now this vapor, if carbon is present in this vapor, this will not react with anhydrous copper sulfate. Then what happens? Here this vapor is going on like this. Okay, so here one pipe is there. This pipe is connecting to this one beaker, right? One beaker is there here. So in this beaker, lime water is there. Lime water is there. Calcium hydroxide, CaOH twice, right? So in this lime water is there. So now this vapor is reacting with this lime water. Whenever this vapor is reacting with lime water, if we get the milky color, then this milky color is the good indication of carbon dioxide. That means carbon dioxide is also present in this vapor. Whenever on reaction with this lime water, okay, if this lime water will turn to milky color, this milky color represent carbon dioxide. So whenever we have the carbon dioxide, that means carbon is present in this organic compound. So this is whole experiment. Okay, this is whole experiment. After that, this will connect with the soda lime. We don't need to do that. We don't need to draw the diagram. This is the rough diagram. If you want to have a very good diagram, you can follow NCERT textbooks. Okay, that means here what are the conclusions? So the first conclusion, here carbon is present because whenever vapor is reacting with this lime water, so it turns to milky. That means carbon dioxide present. Whenever carbon dioxide present, carbon is there in this organic compound. That means first conclusion, carbon is reacting with copper oxide. So here carbon, oxygen, CO2. That means balance this reaction, 2 CuO, carbon plus oxygen, CO2 plus 2 Cu. This is the first one. Second reaction, here carbon dioxide present, carbon dioxide with lime water, CaOH twice, that means CaOH twice. So calcium, CaCO3 plus H2O. देखो 4 oxygen, 2 oxygens plus 2 oxygens, 4 oxygens. Here 3 oxygens. Okay, so H2O I can write here. So 1 oxygen, 3 oxygens, 4 oxygens, calcium, 1 calcium, right? 2 hydrogens. Okay, carbon. So balance, reaction has been balanced. So calcium carbonate has been present. So this calcium carbonate color is milky. This is milky in color. when this calcium carbonate is reacting with excess carbon dioxide and water, this will give you calcium bicarbonate, CaHCO3 twice. Okay, again I'm repeating whole experiment. See how you can detect hydrogen and carbon in an organic compound, whether hydrogen and carbon are present or not. First of all, I am taking organic compound and copper oxide. I am heating this organic compound or burning this organic compound with this copper oxide. Vapors released. These vapors are passing through this container. In this container we have anhydrous copper sulfate. This anhydrous copper sulfate initially at the white color. So after passing this gas, if this white color turns to blue, that means this is the indication of presence of water. Whenever we have the water, that means hydrogens are present in the organic compound. After that, again this gas is passing through this lime water. After passing through this lime water will get milky color. So this is the indication of the presence of carbon dioxide. When we have the carbon dioxide, that means we have carbon in the organic compound. We have totally 4 reactions. You have to remember this reaction and this reaction here. And also, what are the hydrogen reactions? So I have already given you hydrogen plus copper oxide. Hydrogen plus copper oxide. Here 2 hydrogens, so H2O plus Cu. This is one reaction. Second reaction, H2O plus copper sulfate, CuSO4, 5H2O. Okay, so these 2 reactions you have to remember. 1, 2, 3, 4. So total 4 reactions you have to remember. So finally I'm writing here 4 reactions. Only you have to remember 4 reactions here. These are very, very important. You don't need to remember the total process. So the first reaction, hydrogen plus copper oxide, is gives rise to what? Second reaction, water plus copper sulfate. Third reaction, carbon plus copper oxide. Fourth reaction, carbon dioxide, CaOH twice, right? So this copper sulfate, white color here. So initially here 2 hydrogens, so here H2O plus copper, here H2O, CuSO4, so CuSO4, 5H2O. So this is blue color, right? Next, here carbon, 2 CuO, CO2 plus 2 Cu. So final reaction, this is CaCO3 plus CaCO3 plus H2. Okay, again it is reacting with excess of carbon dioxide and water, to give CaHCO3 twice. Okay, so these are the reactions you have to remember. So this is the today's class, and that's all. Thank you so much for watching.